Why did Google sign a secret multi-billion-dollar contract to purchase energy from a nuclear reactor that hasn't even been completed? And why, deep in the Gobi Desert, is a machine whose blueprints the U.S. abandoned 50 years ago finally reaching full power to change global energy history this very week? While we worry about skyrocketing electricity bills and the environmental crisis, the world's smartest minds are betting on technologies once dismissed as scientific jokes. Today, the deadline for dream energy is being shattered by thorium and small modular reactors, or SMRs. This isn't just for nuclear engineers. It's about a secure future for parents who want their children to grow up in a world with clean air, and for professionals watching AI consume nearly 10% of the world's power. Today, I'll take you inside the secrets of the Gansu Desert and the billion-dollar deals of big tech that prove the era of fossil fuels is ending much faster than you think. To understand why this is happening now, we have to look at the two biggest fears regarding traditional nuclear power: safety and waste. Traditional reactors are mostly light water reactors, which use solid uranium and high-pressure water for cooling. If power fails, as it did at Fukushima, the cooling stops and the reactor can melt down or explode. But the technology China is now leading with, the TMSR-LF1 in Gansu, proved in June 2024 that there is a smarter way. Engineers have replaced solid fuel rods with a liquid mixture dissolved in hot fluoride salts that serve as both the fuel and the coolant. For parents concerned about safety, you need to know about the freeze plug. It is a masterpiece of passive safety that works purely on the laws of physics, requiring no electricity or computers. Imagine a plug made of frozen salt blocking a pipe below the reactor. If the temperature rises too high or power is lost, the plug melts naturally and all the liquid fuel drains by gravity into a secure underground storage tank. The reaction stops instantly and automatically. Scientists call this walk-away safe because you can literally walk away from the plant during an emergency and it will shut itself down safely. But why thorium? The answer lies in sustainability and cost. Thorium is 3 times more abundant in the Earth's crust than uranium and can be found almost anywhere in the soil. It produces 200 times more energy per unit of fuel compared to traditional systems. Most importantly for the environment, thorium reactors aren't just efficient, they are waste burners. Research from Westinghouse indicates we can use fast reactors to transmute hazardous waste from old nuclear plants into energy, reducing its radioactive lifespan from tens of thousands of years to just 300 to 500 years. We are turning a crisis for our children's generation into a treasure for our own. While China leads in thorium, Western tech giants like Microsoft, Amazon, and Google are betting on small modular reactors, or SMRs. Forget the image of massive mountain-sized power plants. SMRs are compact reactors, often under 300 megawatts, that can be factory-built as modules and assembled on-site like Lego blocks. This modularity allows them to be placed right next to Google's data centers or industrial factories that need 24/7 carbon-free power. Tech professionals should realize we are entering the age of electricity. AI models are driving power demand to record highs, and big tech needs stable baseload power that solar and wind alone cannot provide when the sun goes down or the wind stops. Data from the IEA suggests that mass-producing SMRs in factories could reduce construction costs by 40 to 60% and cut build times to just 3 to 5 years compared to the decade required for large plants. Today, there are over 80 SMR designs worldwide, from GE Hitachi's BWRX-300 to high-temperature gas reactors like X-Energy's XE100, which can even produce clean hydrogen. The secret weapon in this race is AI itself. We are now using AI and digital twins to simulate plasma behavior and salt corrosion with extreme precision, overcoming the material science hurdles that stopped us in the 1970s. This isn't just about physics and stock market numbers, it's a structural shift for humanity. We are moving from a world dependent on scarce, polluting fossil fuels to an era of abundant, clean energy from thorium and safe SMR technology. A world of cheap electricity and clean air for our children is no longer a sci-fi dream. It is a project currently breaking ground in Gansu and in modular factories across the globe today. Get ready, because the greatest energy revolution of the 21st century has begun, and those who understand these technologies first will hold the reins of the new world.